Behind me now, you see some jagged red peaks. Those are a rock type called rhyolite that is effectively a volcanic rock, and it's a very high silica content volcanic rock. It extends, it's very similar to the rhyolite that underlays the Jarbidge Wilderness area to my north, and so it's called the Jarbidge rhyolite. That's the base of a sequence, or near the base. It's been dated about 15 million years old, and underneath it is a sequence, a thin sequence of rocks, including some lacustrine rocks, but also a thin layer of volcanic tuff that some scientists, Joe Colgan and Chris Henry, dated at about 17 million years. And so that's the very base of a formation that we know as the Humboldt Formation, and the rhyolite is within the Humboldt Formation. So as the normal faults were operating, the downgoing plate was sagging and created room for rocks to erode off the mountains and accumulate in the down-faulting plate. Here, we've had 5 kilometers of sediment accumulate in that way. And so it's really, even though it's poorly exposed, it's an extraordinary opportunity to see the surface sedimentary record of the uplift of the mountains and their erosion and the sedimentation. And that sequence, the Humboldt Formation, extends all the way to the outskirts of the town of Wells to the east, and is approximately 5 kilometers thick in total, and that's the thickest of any place that we see it. And that gives us a really valuable record of that extends up to about younger than 10 million years in the upper part of that formation. And all of those rocks would have been deposited flat-lying. They were rotated over time to dips as high as 40 degrees, to inclinations as high as 40 degrees. All that has to have happened in the last 17